Hello, and welcome to Module 2, which is what we're going to be talking about, transformations. So this is lesson 9.1, and our 3 learning targets are going to be perform transformations on the coordinate plane. And again, a transformation is just a moving, a shifting, a flipping, a turning of an object, and on the coordinate plane means a graph. The second one is identify characteristics of transformations that are rigid motion and non-rigid motion, which we're going to talk about in a second. And then represent a transformation as a function using coordinates and show how a figure is transformed by a function. So we're going to kind of be writing a rule for how we moved our object. So to start off, this 1000% applies to a band. So here we've got Mr. King and the marching band. Here we've got Mardi Gras Parade, which I look a little puppy in the corner. We go to every year. Here's Mr. King, the band director. Here is our Fulton High School band at a football game, and so we're going to kind of talk about their formations and how they apply to geometry from band camp. Okay, so let's talk about this. So it says Mr. King is directing the Fulton High School marching band. He uses the coordinate plane, which he really does this, to plan to represent the football field. For the band's first show, he's going to arrange the band in a rectangle that is 6 marchers wide and 9 marchers deep. So here are our marchers. They are all spread out nice and evenly. The band begins marching down the grid in this formation. Then the marchers move apart from each other vertically while keeping the same distance between the marchers within the same row. The diagram below shows the initial shape of the marchers and the 2 transformations that they undergo. To describe and classify the transformations, compare the pre-image to its image. So let's take a look at some vocab terms up here. Transformation is going to be a change in the position, which means location, where it's located, the size, so bigger or smaller, or the shape of a figure. So it can become a triangle to a square, etc. A pre-image, the prefix pre means before, so it's the original image. Okay, it's the before one, it's the one we started with. The image is the one afterwards. So pre-image is the first one. The image is what it looks like after something happened to it. Okay? So here is the transformation that we have the band. Here is the band at the starting point. It underwent a transformation number 1, and then it also did a second transformation. So what I want you guys to do is in your own words describe what happened in transformation 1. So what happened from this image to the other image. And then number 2, compare the first transformation with the second transformation. How do they compare? So how are they similar? How are they different? Etc. So try 1 and 2, jot some answers down, and then we'll discuss it in a second. So press pause, go. Alright, so on the first transformation, I said it moved down. That's all it pretty much wanted. They were in this exact same vertical line, but it was just shifted down. The second one, they are a little bit different because the first one keeps the same shape and the same size, but the second one is stretched vertically, so it got longer. So if you said anything along those lines, that would be good. So the first one kept the same shape, the second one did not. It kind of stretched vertically. All right, moving on. So transformation 1 is an example of rigid motion. So let's read this math term over here. Rigid motion is a transformation that preserves, which means keeps. It's going to keep the same size and the same shape. So rigid motion is very much like it's rigid. You can't fold it. You can't smush it or anything. It's like something very hard that can't be changed. So it's going to keep the same size and it's going to keep the same shape. So that is rigid. So rigid motion keeps the same distance between the 2 points that are transformed, aka the band. The shape and the size of the pre-image and the image are the same. The original image is the same as the new image. So which of the following transformations above is going to be rigid then? So is it going to be transformation 1 or transformation 2? So the answer is transformation 1 because it's keeping the same size and the same shape. Okay? So again, this transformation 1 didn't change the size, didn't change the shape, it just moved its location. So this is an example of rigid motion. Transformation 2 would be an example of non-rigid because its shape changed, it got bigger, smaller, etc. Okay? All right. Let me know if you have any questions about rigid versus non-rigid motion. Otherwise, we are going to move on. Here's the band again. So we're going to work on number 4. Move my face. So let's review transformation 1. So we are only looking at transformation 1 for number 4. Each point in the pre-image is mapped to a point on the image. For this reason, the transformation can be expressed as a function. So all the points go to another point, aka that would be a function. I want you to complete the table. So for example, let's look at the picture. So it says the coordinate point 110 became the coordinate point 14. So 110 is 1 and then up 10, so it's this top left part of the band. So the top left part of the band still went to the top left part of the band, so ordered pair 110 became 14. That was its ordered pair. So that is what this table is representing. So I want you to finish the table for the other corners of the band. I want you to describe in your own words how the transformation is changing the x and the y coordinates. So take a look at the x coordinates and compare them. Take a look at the y coordinates and compare them. And then C is a bit tricky, but see if you can come up with a notation. For example, 1 went to 1 and 10 went to 4. See if you can come up with a rule that will happen for any shape. Okay, C is kind of tricky. Maybe you can just do A and B, and I'll help you with C later. But press pause and see if you can try A, B, and C. All right, so the answers to the table, 1, 2, which was the bottom left of our band, went to a positive 1 and then a negative 4. So I found that by going 1, 2, became a 1, negative 4, and etc. The top right became the top right over here, which was located at a 6, 4, and then last but not least, 6, negative 4. So if you have any questions on how I got my ordered pairs, let me know. But for part B, I'm going to look at my x and my y values. So hopefully you notice the x's did not change. So the x's stayed the same. They remained constant. So I said that the x's remain the same. The y coordinates are going to change by 6, and they subtracted 6. So a 10 became a 4 by subtracting 6. 2 minus 6 is negative 4. 10 minus 6 is 4. 2 minus 6 is negative 4. So they subtracted 6 from your x coordinates, y coordinates, sorry, and the x's stayed the same. All right, so if I'm going to write a rule for that, my x's didn't change, but my y stayed the same. So you're going to start off your function with x comma y arrow. Okay, so you're taking some ordered pair and something is happening to it. Now, if the x's are staying the same, x is going to go onto x. Okay, so the x value is not changing, but my y values decreased by 6, so I took y and subtracted 6 from it, which is how I get y minus 6. Okay, so this is how you would write a function rule to describe the transformation. So you'll always start with x comma y with an arrow, and then my x has stayed the same, so there's no number. My y is subtracted by 6. Okay? All right, so that was looking at transformation 1, and we're going to move on to transformation 2. So I want you guys to try number 5, looking at transformation 2. So compare the pre-image B, so you're looking at this shape and comparing it to this shape. So again, the top right band members are staying the same, so 1, 4 becomes a 1, 8. So 1, 4, the top left, became a 1 and then an 8. Okay? So again, try A, B, and C, and then we'll go over our answers. So press pause. All right, so the answers to our table are like such. So 1, 4, the bottom left part of my band became 1, negative 8. So 1, 4 became 1, then negative 8. And then I need to write the top right and the bottom right part of my band members. So 6, 4, or in 6, negative 4, they could be in any order. But 6, 4 became 6, 8, and then 6, negative 4 became 6, negative 8. So for any given point, how did the transformation change the x and the y coordinates? So again, our x values did not change whatsoever. So 1 was 1, 1 was 1, 6 was 6, etc. But the y values, something happened to them. And you would almost think they added 4 in this case, but then this is subtracting 4, and then adding 4, and subtracting 4. So I actually have to think in terms of multiplication. And so 4 times 2 is 8. Negative 4 times 2 is negative 8. So they're actually being multiplied by 2 in this case. So since the shape changed, that kind of shows it was multiplied versus not adding or subtracting. Okay. Part C says, can transformation 2 be expressed as a function? Explain why or why not. This may have been tricky because it didn't look like the same from the previous problem, but it can still be expressed as a function. So yes, although it is non-rigid because it changed shape and it got stretched, each point or marker in the pre-image is mapped to a specific part in the image. Okay, so the function is actually going to be x comma y arrow. It's always this. My x values did not change, but my y values are multiplied by a 2. That's why I have a 2 in front of the y. Okay, so let's say the points were multiplied by 3, then this number in front would be a 3. If I took half of all my points, maybe I would have a half in front. Okay, so if it is a non-rigid image, it could probably be due to multiplication, and that is how you would write the function rule. Okay? All right, let me know if you have any questions. Otherwise, we're going to move on to a last example problem. So it says, draw each image on the graph and show how the pre-image is transformed by the function, then classify the transformation as rigid or non-rigid. Okay, so I want you guys to try A and B. What may help you get started is to write the coordinate points for each image. So for example, this bottom left part of my rectangle would be 1, 2, 1, 2. So this corner is at 2, 2, and then the top left would be 1, 2, 1, 2, 3, 4, 5. Okay, so you're going to use this rule. You're going to add 3 to your x values and don't add anything to your y values, and then graph that. Same thing for here, you're going to multiply your x values and your y values both by 2. So again, writing down the order pairs may help you out, but see if you can try A and B as much as you can, and then we'll go over our answers. Press pause and try now. So here's what your new shape should look like for the first one. So this plus 3 just shifted it to the right 3 units. So originally it was at a 2, and then it became starting at a 5, it ended at a 5 and became an 8. So what I did to help me out is first you can list all the order pairs to the side and then kind of draw an arrow and then make sure you add 3 to your x values. So 2 plus 3 is 5, 2 plus 3 is 5, 5 plus 3 is 8, 5 plus 3 is 8. And the y values did not change, so I just repeated 5, 2, 5, 5. And then I just graphed it. Okay, so if you can do that in your brain, awesome. I like to write out the order pairs to help me out. Okay, and this would actually be an example of rigid motion because it did not change the size or the shape, it remained the same. Let's look at B now. So B, I wrote down my order pairs at a 1, 2, 1, 5, 3, 5, and 3, 2. I wrote them over here and I multiplied the x values and the y values by 2 to get 2, 10, 2, 4, 6, 10, and 6, 4. I then graphed my new order pairs over here. So this shape got bigger and it kind of moved a little bit direction. So this is going to be non-rigid because it changed size. It got bigger, it kind of doubled. Okay, so let me know if you have any questions. So notice that rigid is going to kind of be adding or subtracting in our function notation, and then non-rigid, maybe multiplying or dividing. Okay, so let me know if you have any questions on that. Otherwise, thank you for watching 9-1. So remember our 3 learning goals were to perform transformations on the coordinate plane, so move things around, identify whether they are rigid or non-rigid, which we just did, and then represent a transformation as a function using coordinates. So again, this would be writing it as a function, okay, where we have that x comma y arrow with the rule. Okay? All right, thanks for watching, and you can go ahead and watch 9-2.